In this problem, I'm asked, what is the empirical formula for a compound containing 39.22% phosphorus and 60.78% oxygen? So our step one is to make those percents grams. So in my what do you know, we're going to list the elements. We have phosphorus, and I have 39.22, but instead of writing percent, I'm going to simply make it a gram. Oxygen, we have 60.78. Again, instead of percent, we're going to make it a gram. The second part of part one is to convert this to moles. To get the gram to become a mole, we're going to put gram on the bottom so it cancels out, and we put 1 mole on top using our stoichiometry. So again, for the second part of step one, we're going to convert our units to moles. Now, when we go to get the number for the bottom, we're going to use our periodic tables and find the GFM of this element. This 39.22 only represents the phosphorus. 60.78 only represents the oxygen. So we're going to use those individual masses as their GFM. Phosphorus is 30.97, oxygen is 16. 1 on top, 1 on bottom means we're going to be dividing. When you go and put these into your calculator, be sure to hang on to 3, maybe 4 decimal places to have that precision. Phosphorus is 1.266, and the oxygen comes out to be 3.798. The second step says to divide all your answers by the lowest result. All right, the lowest result is the 1.266. So we're going to divide these, and my phosphorus turns out to be 1, and oxygen comes out to be really, really, really close to just being 3. Our hope is that these turn into whole numbers, because then we can jump right to step 4, which is simply placing these as our subscripts, and we come out with phosphorus is 1, oxygen is 3, and that is the empirical formula. Continuing this problem, we want to find molecular formula. So using the empirical above, the P1O3, I want to know what is the formula, molecular, what it's actually to be, if the mass is 474 grams per mole. This we already have step 1 because we have the empirical. Step 2, we need to find the GFM. So phosphorus, I have 1 of them, which is 30.97 grams per mole. The oxygen, there are 3. I'm going to multiply by 16, and that is going to give me a GFM of 78.97 grams per mole. Step 3 is to take our molar mass, that 474 grams per mole, and divide it by our GFM, which was the 78.97. When you divide this, you come out with a whole number of 6. Yes, this must be a whole number because we're going to take the phosphorus and the oxygen, multiply it by that amount, and get the molecular formula of P6O18. That is our molecular formula result.